Alright guys, so this is 2.7 modeling quadratics. So the first thing we're going to do is the vertex of a parabola is 5, negative 3, and the parabola passes through the point 7, 2. Write a function that represents this parabola in vertex form. So we know the vertex h, k. We know the point x, y. So for these questions, we need to just plug in everything we know. We know y is 2 from our point. We know that that's equal to a. We don't have an a value. We know x, in this case, is 7. We know h is 5. And we know k is negative 3. So now we have all the information we need to solve for a. So we have 2 is equal to a. 7 minus 5 is 2 squared minus 3. I'm going to add the 3 over. That gives us 5 is equal to a times 4. So you divide by 4 on both sides, and you would get a is equal to 5/4. So now you can write y is equal to 5/4 x minus 5 squared minus 3. And that would be our quadratic in vertex form. The next one says write a quadratic function in vertex form for the parabola that is shown. Again, we know the vertex, so we know h, k. We also know a point, so we know an x and a y. So this is the same exact question. So y is 1. We have an a value that we do not know yet, okay? And then we have our x and our y, or our x and our h is going to be 1 for x plus this time 1, because this would be minus negative 1, squared, and then plus 5. So we're solving for a, so subtract 5, we get negative 4 is equal to a. 2 squared, so 2 squared is 4, so we're going to divide each side by 4, and that gives us negative 1 is equal to a. So y is equal to negative 1 x minus h squared plus k, and that would be our function. One way you could also look at this is the graph actually shows us that the a value is negative 1, right? If we go to the right 1, you go down 1. Right, so normally x squared functions, if you go 1 in the x direction, you would go 1 in the y direction. But instead, we multiply that by negative 1, and we go to negative 1. Same thing, if we go 2, you would go to 4 normally, but if you multiply that by negative 1, you're going to go to negative 4. So you go over 2, so that's over 2. It would go down 1, 2, 3, 4, so negative 4. So that tells us that the a value that we should have had was negative 1. All right, last one on this page. It says write a quadratic function for the parabola that is shown. It says hint, use intercept form, y equals a, x minus p, x minus q. So why does it say to use that? Because it gives us the two intercepts, negative 1 and 2. So that tells us the intercepts are x plus 1 and x minus 2. Again, we are not sure of the a value here, so we need to find it. We do know another point. We know that we have an x that's 1 and a y that's negative 4. So we're going to say negative 4 is equal to a. And then that's going to be 1 plus 1 times 1 minus 2. So negative 4 equals a times 2 times negative 1. So that's negative 2. So then we get 2 is equal to a. So our equation would be y is equal to 2, x plus 1, x minus 2. And that would be our equation. All right, so that was just like basically a couple of review problems from yesterday, just plugging in what you know to solve for what you don't know. For this next section down here, I'm going to switch over to showing you how to do this. What we're going to do now is we're going to model with quadratic regression. So it says using a graphing calculator for number 4, find the quadratic regression equation that best fits the points. We've done this before, but with linear regression. So it says select stat and then edit. So stat is right here. We're going to click, and then we're going to click enter on edit. This will bring up our lists. If we have stuff in them, just go to the top of the list, click clear, and then click enter. Go up to list 2, click clear, and click enter. Careful not to click delete, because delete will literally delete the list. All right. So now we need to enter in the points. So we're going to use list 1 for our x's. So the x values are negative 4, negative 1, and 2. And then the y values are 1, 6, and 20. And then it says select stat and then arrow over to calc. So we go stat and then calc. Normally we were using linear regression. Now we're going to go down to 5, which is quadratic regression. Click enter. Newer calculators will come up with this menu. In older calculators, it's just going to be a singular line. Okay, so for everybody though, newer calculators, we scroll down to store regression equation. If you're on an older calculator, you just need to click vars right now. So we click vars, we go yvars, we go function, we go y1. So now it should say, if you're in an older calculator, it should say y1 up here at the top of your screen. Newer calculators, it's going to say y1 store regression equation. So in both cases, it's going to store the regression equation in y1. We click enter, calculate, boom, there's our regression equation. So we can write that out. It's telling us that our a value is 1/2, so we're going to say y is equal to 1/2 x squared. The b value is 4.166 repeating, so plus 4.16 repeating x. And then the last value is plus 9.6 repeating. Okay. Then it says use the graph to find the value at x equals 5. So we go y equals. Okay, we make sure our graph is in here. We know that it's opening up and the y-intercept is at 9.6. So what might be helpful is to open up our window a little bit. So I'm going to say -10 in the x's is probably fine. Let's go a maximum of, we only need 5 actually. So let's go a maximum of 10. We'll stay there. Maybe our y's need to open up. Sorry, mine's apparently that. I'm going to say -10 for y min. Let's go y max though. Let's go kind of high just to make sure we get that in there. Then we click graph, see what happens. All right, it doesn't look like I quite make it to 5, but if we click trace, we click 5, we click enter, it still takes us there because we have at least 5 in the x direction. So at x equals 5, you get a y value of 43. So 43 would be the answer for that second part. For question number 5, it says we're going to do a pumpkin tossing contest. People compete to see who can catapult their pumpkin the furthest. One catapult launches pumpkins 25 feet above the ground at a speed of 125 feet per second. The table shows the horizontal distance in feet the pumpkin travels when it's launched. Use a graphing calculator to find the best fitting quadratic model for the data. So we're going to do that whole process again. Stat, we need to edit, and then we're going to clear our lists. So list 2, clear that. List 1, clear that. And we're going to fill our new data. So let's see what it wants us to have. It wants the table to show horizontal distance in feet. Okay, so let's make our angle x, and then we'll make the horizontal feet our y value. So our angles are going to be 20, enter, 30, 40, 50, 60, and 70. And then our y values are going to be the distance in feet, so 372, 462, 509, 501, 437, and 323. Okay. From here, we need to get the equation, so we're going to go stat and then calculate all the way down to quadratic regression. Click enter. Again, we want to store this into y1, so we're going to go vars, yvars, function, y1. Calculate this. So our regression equation is y equals, let's go 3 decimal spots, so -0.261 x squared plus 22.591 x plus 23.029. Okay, it says using your model and graph, at what angle does the pumpkin travel the furthest? Okay, so it's asking for the furthest. If we look at that, if we look at the graph or the table that we're given, it looks like between 509 and 501, we go from going up to going back down. So we need to look somewhere between 30 and 50. So 462, 509, and 501. So when we build our y equals, It's in there. Good. When we build our window, we know that we're going to want to be up in the 500s. So I'm going to go basically from 450 in my Y minimum. So I'm going to go from 450 all the way up to, I don't know, let's just say 550 to be safe. I'm going to count by tens, so that looks okay on my scale. For my X minimum, we said 30, so let's go like 25. For our X maximum, we said 50, so I'll just go 55, and I'll count by fives here. And then I'm going to click graph. This should give us a nice graph of this little section. Boom. All right, and the furthest distance horizontally would just be the vertex, right? We need to find the vertex, so we're going to go second calculate. We're going to go maximum. Okay, so I'm to the left for sure. Scroll over till I'm to the right for sure. Okay, we're going back down now. Click enter again. And it looks like the angle that chucks the pumpkin the furthest is going to be 43.208 degrees. And that's because the angles are our x values in our lists. So our x value right here tells us exactly where that angle would be. And the furthest distance that it would travel is 511 feet. All right. So that's how you use quadratic regression in your calculator. As always, guys, let me know if you have any questions. Just shoot me a message in Canvas.